In this question, you have a water wave that's traveling to the right, and which of the following statements are not correct? That means to say not true. Now, of course, let's look at the four options here and see which one is correct. Now, first one, part one, okay, here, particles at x and w, they are in phase. In phase means they have the same speed, same direction, same displacement, or you can say same velocity. So, and if you know that two particles are in phase, meaning to say they are basically, as long as they are one wavelength apart or at the identical point, all right, that will be in phase. So in this case, both are at the crest. Okay, it's one wavelength apart. Definitely x and w are in phase. Likewise, if this point, the trough here and here will be in phase. Same thing, if I start from here, here will be in phase. And how about these 2 points here? They are out of phase. Okay, moving in opposite direction. Okay, so this one is true. That's correct. Next one, particle at x will move to w after a period. All right. Now, this one definitely is wrong because you know that this is a transverse wave. Transverse wave, as the waves move to the right, the particle only vibrate up and down, okay, perpendicular to the direction of the wave. So that means to say this x, one complete wave later, let's talk about after a complete period. So it will go down, that's half a period, then you will go all the way back to its original position. It will never move to the right. So option number two is wrong. And just to sidetrack a little bit, what if they say that if it's moving from here to here, how long will it take? That will be a quarter of a period, half a period, 3/4 of the period, and then back to its original position. That's one full period later. All right. And option number three, particle at z here, all right, will move up the next moment. Now, I hope you can still remember the techniques. How do you know whether the z here is going up or down? All right, so what you need to do is draw the dotted line to link all the crest and the trough. Then, since the wave is moving to the right, let's sketch out the position of the wave the next moment. So every point will be shifted to the right. So this is the new position of the wave the next moment. Basically, every single point you shift to the right. All right, you have to draw it correctly in a way. If it's drawn out of shape, okay, if you draw out of shape, it will be very difficult to determine. So next, once you have drawn the wave the next moment, z here is, you can think of it as like a object floating on the water, just like a coconut going on the floating on the water. It has to be on the water. Since right now it's here, the next moment it will be going up on the wave. All right, so likewise for this, x of course is at the highest point already. The next moment you'll be going down. So even here, the next moment it will be going down, and here the next moment will be going up. So use these techniques to determine, all right, instead of just guessing. So you will move up, so that is correct. And the fourth option is wavelength of a wave is represented by xy. Now that's wrong. You should know that the xy here is the maximum displacement from the rest position. Okay, likewise here to here, that is called amplitude, not wavelength. So if you look at it, option 2 and 4, they are wrong. So the answer is B. All right, so hopefully you can remember all these various points about the transverse wave. All right, thank you.